All right, synthetic division time. Now, hopefully you've seen the long division video. It is helpful. It takes longer than it does with synthetic division. Now, here's the problem with synthetic division, though. I don't recommend you always use it. Long division always works, okay? But synthetic division is faster, easier, but it's really only ideal in one type of circumstance, okay? So let me talk first. This is when you probably do not want to use synthetic division. Okay, I want to identify the differences before we even get started. When you're dividing by something where the front coefficient of the binomial is larger than 1, a 2x, a 3x, a negative 7x, anything other than 1, use long division, okay? But notice if I have like an x minus 3, an x plus 2, if it is a singular x in a binomial, synthetic division. Singular, synthetic. Just remember that. And it'll be much, much faster. Okay? Here's what synthetic division is. Synthetic division takes a look at your polynomial, and it looks like this. They set it up, you'll see a little box and a line. Here's what happens. Look at what you're dividing by. X minus 3. What is the root or the 0 that represents? 3. 3. That was fun. Does everybody understand if you were to solve this, you'd get 3? The root goes in the box, okay? All your coefficients come down. Coefficient of 3, negative 14, 15. That's the setup. I haven't done anything yet, but that's the setup. The root goes in the box, coefficients chimone down. Now, remember this pattern. Add down, multiply, replace. Add down, multiply, replace. Here's what that means. Your first coefficient, add down. Multiply, we'll get 9, replace. It's that simple over and over. Add down, multiply, replace. Add down. Now, here's what this does for me. Notice you started, your first polynomial is a squared, a degree 2. When I divide, it takes it down one level. So these are my new coefficients for my result, and they start one level below quadratic. So this gives me my answer. If I started at squared, I'm picking it back up. It's 3x minus 5. And notice I just walk my way down. Done. Isn't that nice? Synthetic division works really well if you can, first off, have the right scenario, and 2, remember the pattern. Add down, multiply, replace. Add down, multiply, replace. So let's take a look at this one. Now, this one, again, a little tricky. Notice the gap. Goes from a cube to a linear. It skips the degree 2. You cannot. You cannot. So let's set up the box with the coefficients. X plus 2, what's the root? Negative 2, that's right, good job. Bring my coefficients down, but I told you not to skip degree 2. Which means there's a 2 coefficient for the third degree. There's none. Oh, what's the number for none? 0 for the squared term, negative 2 for the linear term, and 1 for the constant. All right, look how nice and fast we can do this problem. You remember the pattern? Add down, multiply, box, replace. Here we go. Add down, multiply, replace. Add down, multiply, replace. Add down, multiply, replace. Add down. Now you'll notice something here. This one had a 0 remainder, so there wasn't anything back here. This has a remainder. This is the last box. This represents the remainder. You will also see synthetic division when we start talking about remainder theorem. It's a way to evaluate functions that's very, very fast and helpful. Now let's write our final answer. We started cubed, one level down, now we're squared. 2x squared, walk it down, minus 4x, walk it down, plus 6, remainder, it's negative. So I am minus 11 over, what was I dividing by originally? X plus 2. Quick tutorial on synthetic division. If you can use it, do it. It's nice and fast. Hope it helps.